Good evening, Swati.
Good evening, ma'am.
Good evening. Did we finish this one in the last class?
Yes, ma'am, we have completed. You told
We have
us to write
completed.
it down, ma'am. Yes, ma'am.
Okay, fine. So let's just recall the relationship between inner radius, outer radius, and the thickness. Let me show you the cross section of a hollow cylinder. I'll show you the cross section of a hollow cylinder. There are two concentric circles. The cross section of a hollow cylinder is a ring. Ring is the region. This is a ring. It's the region between two concentric circles. It's the region between two concentric circles. This flat portion is called the ring. The area between these two concentric circles. These two circles have the same center, but different radii. So small r represents the radius of the inner circle. Capital R represents the radius of the outer circle. The difference between the outer radius and the inner radius is the thickness. The thickness of the material. Now we are talking about a hollow cylinder. So the cylinder is made of some material. That material is thick. The thickness of the material is the external radius minus the internal radius. And the thickness is given by the letter W. Thickness is given by the letter W. Now this is smaller. This is the thickness of the material. So clearly we see that capital R is equal to small r plus width. You can see here from here to here is the inner radius or smaller. And this is the thickness of the material the cylinder is made of. So we can see what is the line segment from here, from the center to a point on the circumference of the outer circle. This is the center. This is a point on the circumference of the outer circle. So this line segment represents the radius of the outer circle. From the center to a point on the outer circle represents the radius of the outer circle. And what do we see? On the outer radius, we see the inner radius and the thickness. The inner radius and the thickness put together forms the outer radius. So this is one relation. Outer radius is equal to inner radius plus the thickness. Have we made note of all this? We understood three things in the last class. Then we also understood that small r is capital R minus thickness, and the thickness is the difference between capital R and small r. Do you have all this in your book, Swati?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Oh, there's somebody else in the meeting. Yeah. Good evening, Bhavishya.
Good evening, ma'am.
Yeah. Now, talking about W. So this is the inner radius. This is the inner radius. This is the outer radius. This is the outer radius. From here to here is the outer radius. So we see that the outer radius minus the minus the inner radius. See, if you take away from the, let me draw again. This full thing is R, correct? This full thing is capital R. This full thing is capital R. Now from capital R, this full thing is capital R. From this, if you remove smaller, if you take away smaller, see, if you remove this, if you remove smaller, this one, see, you're left with the thickness. You're left with the thickness. So capital R minus small r is the thickness of the material, or W is equal to capital R minus small r. Again, small r is equal to capital R minus the thickness. Small r is equal to capital R. The capital R, that is the outer radius, minus the thickness. If you remove this, you get smaller. So small r is equal to capital R minus thickness. So it's enough if you remove, if you remember any one, from that you can get the others. Maybe you can remember that the thickness is equal to the outer radius minus the inner radius. So from this you can transpose and get the others. So when you transpose, what do you get? Capital R is equal to width plus small r. Can we see that when you transpose?
Yes, ma'am.
See, the width
Yes,
is
ma'am.
equal to, capital R minus small r. So capital R is equal to, when you transpose minus R, it will become plus R and plus W. So R plus W is equal to capital R. And if you want to know what small r is, see, so I said you can remember only this, only this. So if you want to know what small r is, so take this to the other side. When this transpose this one, so it will be R is equal to capital R, and bring this here, minus W, minus W. You can find the others. If you just remember, the thickness is equal to capital R minus small r. That is the outer radius minus the inner radius. From this, you can get the others. From this, you can find what is capital R and what is small r. So you can just transpose in your mind. You can see that capital R will be, if this goes here, small r plus the thickness. And small r, if you transpose this here, small r will be capital R minus the thickness. So this is what we understood in the last class. So in this question, so to work anything about a hollow cylinder, you need these values. You need the value of the inner radius, outer radius, and the height of the hollow cylinder. For a cylinder, you normally need radius and height, but since this is a hollow cylinder, the material is thick, you have two radii, one inner radius, one outer radius, and the height. So you need these values to calculate volume or surface area of a hollow cylinder. We finished this, is it, children, in the last class?
Yes, ma'am.
What about this one? Did we do this in the last class?
No, ma'am. No, ma'am.
Yeah. Try this. Try this one. So here you will have to find the total surface area, children. Write down the values, write down the question and write the values, meaning the value of capital R, small r, thickness, the height of the tube. Yeah, what's the value of, what do you mean by inner diameter? Inner diameter. So inner diameter is small d, which is 14 centimeters. So the inner radius, don't write anything. I'll show you the answer slide. Inner radius will be 14 by 2, 7 centimeters. Yeah, the thickness of the tube. So W is given to be 2 centimeters. From the inner diameter, we should find the inner radius. Inner radius or small r is equal to 7 centimeters. Thickness W is equal to 2 centimeters. Now we need to find the value of capital R. We know that capital R is equal to small r. That is, outer radius is equal to inner radius plus the thickness. So capital R is equal to 7 plus 2, 9 centimeters. What about the height? The length of the tube is the height of the tube. H is equal to 28 centimeters. So we have all the values. We have the value of small r, capital R, and H. You can answer any question related to the hollow cylinder, that is the tube. So the question is to find the TSA of the tube, the total surface area of the tube. Okay, so now children, listen to me carefully. To find the total surface area, we need to find the inner CSA, we need to find the inner CSA, the outer CSA or the outer curved surface area. You need to find the area of the ring on the top, area of ring on the top, and the area of the ring below, area of ring below, or at the bottom. These are the 4 different surfaces which have to be painted. These are the 4 different surfaces of the tube which have to be painted. You have to paint the inside, the inner curved surface area. Then on the outside, the outer curved surface area. Then there are those flat portions on the top. Because the material is thick, there is one ring on the top and there's one ring below. So these are the 4 different portions we have to paint. So see here how to calculate. See here, children, please listen to me. Yeah, inner CSA of the tube. So you have written all the values, children. Let me write that for you. So inner radius is equal to 14 by 2, 7 centimeters. Just write this. Then W is equal to 2 centimeters. And capital R is equal to small r plus W, which is 7 plus 2, 9 centimeters. And the height is 28 centimeters. Please write all this before you start working the answer. So then now look at this. Inner CSA of the tube. The formula is 2 pi RH. 2 pi RH square units. Now 2 into, don't use the value of pi. You can use it, but listen to this working. Don't use the value of pi. Have pi as it is. What's the value of small r? 7. And what's the value of h? 28. So multiply 2 into 7 into 28 is 392. So 392 pi centimeter square, because you can see that all the values are in centimeter. Now the outer CSA of the tube, 2 pi capital RH square units. So 2 into pi into capital R, 9, into height, same thing, 28. Now 2 into 9 into 28 is 504 pi, this pi. Okay, 504 pi centimeter square. The area of 2 rings. So one ring is pi r square minus r square. 2 rings, so double it, multiply by 2. So area of 2 rings is equal to 2 into pi r square minus r square square units. So 2 pi into, you can see the values. Capital R is 9 and small r is 7. So 9 square minus 7 square. 9 square is 81. 7 square is 49. 81 minus 49 is 32. So outside you have 2 pi, 2 into pi. Outside you have 2 into pi. Okay, so and this difference is 32. So 2 into 32 is 64. 64 pi centimeter square. Now the TSA of the tube, the total surface area of the tube is equal to this answer. Answer this 1 plus 2 plus 3. So 392 pi plus 504 pi plus 64 pi. Now how do you add? It's like adding 392A, 504A and 64A. How do you add this? You will add the numbers 392 plus 504 plus 64. That sums up to 960. Write that A as it is. Similarly, write that pi as it is. You will write A as it is, right? Similarly, write pi as it is. Now, once for all, use the value of pi. So you're only simplifying your work. Everywhere you have to use 22 by 7, and multiply. So that's going to be, that will involve a little more calculation. So instead of using the value of pi everywhere, we find the total surface area in terms of pi and use the value of pi once for all here. Now 960 pi. So 960 into 22 by 7. Into 22 by 7. Now we see that, this cannot be simplified. That is, it's not 960 is not exactly divisible by 7. 960 and 7 cannot be simplified. 960 is not divisible by 7. So what we do, we multiply the numerators. 960 into 22, which is 21,120 divided by 7. Now we have to also find, so we found the TSA. This is the TSA. This is the total surface area of the tube. That is, this is the inner CSA, outer CSA, and the area of the two rings together. Now, the cost of painting 1 centimeter square is 6 rupees 30 paise. The cost of painting 1 centimeter square is 6 rupees 30 paise. So the cost of painting so many centimeter square will be this one into 6.3. That's all. 1 centimeter square, 6.3. Rupees 6.3 or 6 rupees 30 paise. So many centimeter square will be into 6.3. That will be the total cost of painting. So multiply, children. So you'll have to multiply, this one by 6.3. If you want, you can convert this to a fraction also. See, I straight away simplified like this. How 7 ones are 7 and 7 nines are 63. So it will be 0.9. 0.9. And then I multiplied 21,120 by 0.9 and I got this answer, 19,008. You can also write 6.3 as 63 by 10 for the sake of convenience, You can also write, see here, I'll just clear the slide. Please listen to me. You can also write this one as 63. I'll just write it here. It's in 63 by 10. You can take the 63 by 10. So what will happen? The 0 and 0 will get cancelled. And then 7 ones are 7 nines are. Now you have to multiply 2112 into 9. And that will give you this answer. You can also write 6.3 as 63 by 10. I have done it straight away. That's all. Straight away meaning it's divisible, right? So 7 ones are 7, 0.9 times. And then I multiplied these two numbers. 19,008 is the total cost of painting. Wasn't that simple, children? Is it easy to understand?
Yes, ma'am.
Yeah, please work. Any questions, ask me. Very important question. You will learn the same thing in 9th standard and 10th standard.
Ma'am.
Yes.
Ma'am, I'm Nandana, ma'am.
Hi, Nandana. Good evening.
Good evening, ma'am. Ma'am, I
Yes.
don't know that you have now only my mother told that on 6 o'clock you have class. Because
Oh,
I don't have a phone, ma'am, so that
but I sent the message in the morning itself, darling.
ma'am, I didn't see.
Oh.
Ma'am, you completed a lot.
No, darling. No. We just recalled what we did in the last class, and this is the first time they are working.
Okay.
Yeah. I'll be downloading the recording, and you can see the recording by 8:30.
Ma'am, from next week I can't come to the class, ma'am.
Why again exam at school? Huh?
Yes, ma'am.
Oh.
From 16 to 24, ma'am.
16 to 24. Okay.
I can come.
Okay, fine. Swati, I had asked you to share the pictures of your question paper, no?
When, ma'am?
Yeah, I sent a message. I don't know, some 2, 3 numbers I have saved. So one number had sent a message.
I didn't get any message. Ma'am, question paper of my maths worksheet.
Yeah, math worksheet. Yeah.
Yes, ma'am. I'll send it to you.
That number in which you have a GoPuram as a profile picture.
Ma'am, it's my mother's. She mistook that instead of the test, ma'am, that you have written the art.
That is not your number, is it? Okay. So that number only I sent.
Yes, ma'am. I'll
Okay.
send it to you.
Yeah. After the class, you just share your paper with me.
Yes, ma'am.
Okay, thank you. You're done working, children?
Yes, ma'am. No, ma'am. Ma'am,
Yeah.
ma'am, I'm having one doubt in my maths worksheet, ma'am.
Can you share it on WhatsApp with me?
Yes, ma'am.
Yeah, I'll reply that. Yeah.
Yes, ma'am. Ma'am, after the class, can I share it, ma'am?
Yeah, after the class, yes.
Okay, ma'am.
No, you send the question. I'll work it and explain it on WhatsApp to you.
Okay, ma'am.
Yeah. I have a meeting at 8 o'clock today. 8 to 9:15, I have a meeting. So after that, I'll look into the question and answer you. Okay, by 10, I'll post the answer.
Okay, ma'am.
Yeah. Okay, so Nandana might not have finished, but Bhavishya and Swati finished this one.
Last statement, ma'am.
Finished, children?
Completed, ma'am.
Yeah.
Ma'am, can you once again?
1 minute. 1 second. Yeah.
Yes, ma'am.
Okay. Yeah. Just 1 second. All right, yeah, this one. Yes, children. Find the area of a rhombus whose perimeter is 52 centimeters and one of the diagonals being 10 centimeters. We know that in a rhombus, all the sides are equal. In a rhombus, all sides are equal. Okay. All the sides are equal in a rhombus. So the perimeter is equal to 52 centimeters. Since all the sides are equal, perimeter is equal to 4a, like a square. Like in a square, the perimeter of a rhombus is also 4a because all the sides are equal. A plus A plus A plus A. 4a is equal to 52. A is equal to 52 by 4, 13 centimeters. So each side is equal to 13 centimeters. That's why the perimeter is 52. Okay. And the length of one of the diagonals is 10 centimeter. So it can be any diagonal. So maybe you can join this. I don't know what I've done the answer here. Okay, so one of the diagonals is 10 centimeters. So let's take both the diagonals. We'll mark this diagonal as 10 centimeters. By the property of a rhombus, in a rhombus, diagonals are unequal. In a rhombus, diagonals are unequal, but they bisect each other at right angles. In a rhombus, diagonals are, I'll write the properties later. When you're working the answer, no, I'll write the properties for you. You can take it down. In a rhombus, all sides are equal. Diagonals are unequal. Diagonals bisect each other at right angles. What do we mean by bisecting each other? Diagonals bisect each other. That means one diagonal bisects the other diagonal. That means bisects meaning it cuts one diagonal cuts the other diagonal into two equal pieces. One diagonal cuts the other diagonal. That is, the first diagonal cuts the second diagonal into two equal pieces. The second diagonal cuts the first diagonal into two equal pieces. That's why we say they bisect each other. They bisect each other. The first diagonal cuts the second diagonal into two equal pieces. The second diagonal cuts the first diagonal into two equal pieces. That's what is meant by the diagonals bisect. Bisect means two equal pieces. Bisection, trisection, bisection or bisect meaning cut into two equal pieces. Trisect or trisection is cut into three equal pieces. Diagonals of a rhombus bisect each other. That means they cut each other equally into two equal halves and they meet at right angles. They also meet at right angles. So this is 90 degrees. And the length of one diagonal is 10. So it will be 5 here and 5 here because it's cut into two equal halves. Now using Pythagoras theorem, you can find the length of this side. Okay, now so I'll just name this triangle alone. Supposing I call this AOB. In right triangle AOB, by using Pythagoras theorem, we have AO square plus OB square is equal to AB square by Pythagoras theorem. It's a right triangle. AOB is a right triangle. AO square plus OB square is equal to AB square. AO square we don't know, we have to find, plus OB square is 5 square is equal to AB square, 13 square. So on solving this, you will get AO is equal to 169 minus 25, 144. AO square is 144. AO is equal to square root of 144, which is 12. So you'll find AO is 12. This part, AO, half of it is 12. So the remaining half also will be 12 because the diagonal is cut into two equal pieces. If one half is 12, the other half is also 12. So the length of the other diagonal is 24 centimeters. The length of one diagonal is 10 centimeters. The length of the other diagonal is 24 centimeters because one half is 12. AO is 12. So the other half also will be 12. So 12 plus 12, 24 centimeters is the length of the other diagonal. And we know that the formula to find the area for rhombus is half D1, D2, half into product of diagonals. So half into the length of one diagonal is 10 centimeters. The length of the other diagonal is 24 centimeters. And this is Or if I cancel this 12, 120 centimeters square. This is the procedure, children. All right. I'll show you the answer slide. Start working. Any questions you can ask me? Yes, please ask.
Yes, ma'am. Like in rhombus, does a point of bisection is similar in square or not?
Point of you're asking me the property of a square?
No, ma'am. Will the diagonals cross or bisect each other at 90 degree in square or rectangle?
In a square, it will. In a square also, the diagonals bisect at right angles. In a rectangle, the diagonals bisect each other, but not at right angles. In a parallelogram, also the diagonals bisect each other, but not at right angles. Only in a rhombus and a square, the diagonals bisect at right angles. In a kite, the diagonals are perpendicular to each other, but they don't bisect. One diagonal bisects the other diagonal. That is, the bigger diagonal bisects the smaller diagonal. We learn all that in this chapter, understanding quadrilaterals. We learn about all these properties. But now your question was, Swati, if in a what about the property in a square? Yeah, in a square, the diagonals are equal. In a rhombus, diagonals are unequal. In a square, diagonals are equal. In a square, also the diagonals bisect each other. And they also bisect at right angles. Here, the diagonals bisect at right angles, but they are not equal in a rhombus. Is it fine, Swati?
Can you show me the diagonals by drawing a square and a rectangle?
Yeah, sure. So this is square. This is a square. This is one diagonal. This is the other diagonal. 90 degrees, 90 degrees, 90 degrees, 90 degrees. Is this what you asked, Swati?
Yes, ma'am. In rectangle.
In a rectangle, they don't, okay, rectangle, they bisect each other, but not at right angles. Diagonals are equal. In a rectangle, the diagonals are equal. They bisect each other, but not at right angles. This angle will be an obtuse angle. This one will be an acute angle. In this figure, these two angles will be equal. These two will be obtuse angles, and these two will be acute angles.
Yes, ma'am.
Okay. So this D1 is AC, and this D2 is no, D1 is BD. D1 is BD, and D2 I've taken as AC.
Completed, ma'am.
I want to explain again. When all of you finish, please let me know. Nandana has completed. Swati and Bhavisha, let me know when you're finished. Done, girls?
Completed, ma'am.
Yeah. Bhavishya?
Ma'am, last step I'm doing, ma'am.
Okay.
Completed, ma'am.
Okay. So let's see the answer again. So we have to, the question is, we have to find the area of a rhombus. So we know that we can find the area of the rhombus using two different formulae. If the base and height of the rhombus is given, then you can use this formula base into height. If base and height of the rhombus is given, you can use this formula base into height. Or the other formula is half d1 d2, half d1 d2. So here, since information is given about one diagonal, we are trying to find the length of the other diagonal and find the area of the rhombus using the formula half d1 d2. Because we are given that the length of one diagonal is 10 centimeter. So we, with the help of the given information, we find the length of the other diagonal, that is 24 centimeters. And then we find the area of the rhombus using the formula half d1 d2. So now the question is, we know the length of one diagonal. What is the length of the other diagonal? So to find the length of the other diagonal, we need to draw a figure and incorporate, write all the information given in this figure. Only then you get an idea as to how to proceed. Now perimeter is given to be 52. In a rhombus, all sides are equal. So if perimeter is 52, that means 4a is equal to 52. Perimeter is 4a. So from this, you get a is equal to 13 centimeters. So you can see here, a is 13. I just marked one side, every side is 13. I've just marked here alone. Okay, so that's first part. Now, we know that the length of one diagonal is 10 centimeters. So I've taken the shorter diagonal as 10 centimeters. So since the diagonals bisect each other, 5 here and 5 here, that is DO is 5 centimeters, BO is 5 centimeters. Now we apply Pythagoras theorem in this right triangle BOC. And we find the length of CO. And we find the length of CO, 12. So if CO is 12, AO also will be 12. If CO from here to here, if CO is 12, AO also will be 12. That means AC is equal to 12 plus 12. AC, the length of the diagonal AC is equal to 12 plus 12, 24 centimeters. Now we found the length of the other diagonal. And we find the area using the formula half d1 d2. Yes, children. A similar question we have worked from NCERT. I want you to do this.
Ma'am.
Yeah. Yes, Bhavishya.
I'm having doubt, ma'am.
Yeah.
Ma'am, in last some area is RH ABCD, ma'am. Half into how we are getting 10 into 24, ma'am.
Okay. What's D1, D2? D1 is the length of one diagonal. So I have taken it as BD. And D2 is the length of the other diagonal. Other diagonal is AC. What's the length of BD? This one BD. You should not take 5. 5 is not the length of the diagonal. The length of the diagonal is from here to here. The length of one diagonal is 10 centimeters. And the length of the other diagonal from here to here. The length of the other diagonal from here to here is 12. This is another 12. So 24. Is your doubt this one, Bhavishya? Why it's not half into 5 into 12?
Yes, ma'am.
Yeah, 5 is only half of the diagonal. 5 and 12 are only half of the diagonals. The formula is half product of the diagonals. That is a half into, see here, it is here, half into D1, that is BD, into D2, that is AC. What's the length of BD? What is the length of BD? 10 centimeters. What's the length of AC? Pythagoras theorem, you found only CO. You found only CO using Pythagoras theorem. That is 12 centimeters. So AO is also 12. This is also 12. So 12 plus 12, 24. So AC is 24. So BD is 10 and AC is 24.
Okay, ma'am.
Okay. Yeah, you can use your classwork, refer, but do this correctly, all of you. You've done a similar sum. Similar sum earlier. Very important question. You can use the earlier working. You can go through that working and do this, but I want the correct answer from all the three of you. Yes, children? You need help? Okay, so Bhavishya, what are you finding? What kind of solid is a suitcase?
I'm doing now.
No. A suitcase. The suitcase mentioned here is what? Is with solid.
Mom, it's a trapezium. A cuboid, mom. Cuboid, mom.
It's a cuboid. How do we know it's a cuboid?
Mom, it is a suitcase is like a rectangular shape.
Correct.
From the length, breadth, and height of the cuboid.
Yeah, correct. Because the length, breadth, and height is given. You can see 90 centimeters by 54 centimeters by 27 centimeters. One suitcase is 90 by 54 by 27. So from the dimensions, length, breadth, and height, it's a cuboidal suitcase. There are 100 such suitcases. Find the length of canvas needed to cover all the suitcases if the width of the canvas is 108 centimeters. So are you finding the volume or area of this cuboid of the suitcase?
Area of the area.
Yeah, area means you're finding curved surface area or total surface area?
Curved surface.
You're covering the suitcase with canvas all over or only the curved surface area?
All over.
All over means CSA or TSA?
TSA.
TSA. So find the TSA of one suitcase. Multiply by 100. You will get the TSA of 100 suitcases. Do that and tell me.
Yes, ma'am.
Yeah. mic is enabled, please disable your mic. Yes, children, what is the TSA of one suitcase?
17,496 centimeters square.
17,496. Perfect. Perfect. Very good. Now find the TSA of 100 suitcases.
Yes, ma'am.
Yeah.
Ma'am, 17,49,600 centimeters square.
Correct.
Ma'am, I'm also getting the same answer, ma'am.
Very good, children. Very good. So you can see the answer slide here. So you just have one more step to go. So the area of canvas needed, you can see it there. The area of canvas needed is equal to 17 lakhs. You can see here, the area of canvas needed is equal to 17 lakhs 49,600. Now, when you buy this canvas from the market, it is a rectangular piece. It's a rectangular piece. So that means L into B. L into B should be that is the area of the canvas, which is the length of the canvas into the breadth of the canvas, should be equal to 17 lakhs 49,600. See, this is the total area of canvas needed. This is the total area of canvas needed. Now, since the canvas is rectangular in shape, see, when you buy any material from the market, any fabric from the market, it will be a rectangular piece. So when you buy canvas from the market, if you want so much area of canvas, when you buy it, it will be a rectangular piece. So that means L into B, length of the canvas into the breadth of the canvas should be equal to 17 lakhs 49,600. Now length we don't know, but the breadth of the canvas is given in the question. See here, the width of the canvas is 108 centimeters is given. The breadth of the canvas is given. So length we don't know, into 108 is equal to 17,49,600. So L is equal to 17,49,600 divided by 108, which is 16,200 centimeters. So when you divide this by 100, you can convert that to meters. So the length of the canvas needed is equal to 162 meters. How do you convert it to meters? 16,200 divided by 100. It's in centimeter. Divide by 100, it's converted to meters. So the length of the canvas needed is equal to 162 meters. Please complete the answer, children. Please complete it. I'll just come back. I'm sure you're finished, children, all of you.
Yes, ma'am, completed.
Okay. Yeah, this one also. Similar question we have done earlier. Please try. Floor area is given 9,000 meters square. Parallelogram shaped tile of base 25 centimeters, height 40 centimeters. How many tiles are needed to cover the floor? So what are we doing, children? How do you find the number of tiles needed to cover the floor?
Ma'am, the floor area 9,000 divided by the area of the parallelogram.
Very good. The floor area divided by the area of one tile. Each tile is a parallelogram. How do you find the area of a parallelogram?
Base into height, ma'am.
Base into height, correct. But the floor area is given in meter square, while the area of the parallelogram you find will be in centimeter square. So you need to convert the larger unit to the smaller unit. So convert meter square to centimeter square. How do you do that? How do we convert meter to centimeter?
Ma'am, 1 meter equals 100 centimeter.
Correct. 1 meter is 100 centimeter. So will you multiply or divide to convert meter to centimeter?
Multiply.
Multiply by 100. You will multiply by 100. So when you multiply by 100, you will convert meter to centimeter. Multiply by 100 two times to convert meter square to centimeter square. Whatever you do, do it two times. So 9,000 meters square to convert it to centimeter square, into 100 centimeter square. Correct. So the number of tiles will be floor area divided by the area of one tile. Yes, Swati, you were right. Take down the answer, children.
Yes,
So it's very clear that the floor area is in meter square, but the area of the parallelogram, the parallelogram shaped tile, you will get in centimeter square because the base and height are given in centimeters. So we convert meter square, the larger unit, the bigger unit, the bigger of the two, meter, centimeter. Meter is a bigger unit. So we'll convert meter square to centimeter square. That's the first step. And then we'll find the area of one parallelogram shaped tile, base into height square units. So 25 into 40 centimeter square. See, I'm not multiplying because we have to anyways divide later. So I did not find the product. I just leave it like 25 into 40 centimeter square. Because now anyways, we're going to simplify. So see here, this one divided by this one. So now you can cancel here. So 25 ones are 25, fours are 100, 4 ones are 4 tens are 40, and then 1 0 and 1 0 here. So if you're going to divide, you don't have to multiply these numbers. You can take them as it is. Please complete it, children.
done, ma'am.
Okay.
Done, ma'am.
Very good, Nandana.
Completed.
Yeah. So dimensions of a hall given to you. So it's a cuboidal hall. You can see the length, the breadth, and the height of the hall given to you. It's a cuboidal hall. You should find the cost of whitewashing the walls. Only the walls, okay, not the ceiling. So find the cost of whitewashing the walls at ₹5 per meter square. If the area occupied by two doors is 5 meter square each and 4 windows is 1 meter square each. So we know that the doors and windows occupy the space on the walls. Where are the doors and windows? It's a part of the walls. So if there are 4 windows, maybe on 2 walls, 2 windows each. We don't know how the windows are, but then the windows and the doors take up the, are a part of the walls, the windows and doors. They're a part of the walls. So when you find the area of the 4 walls, you are finding the area of the doors and windows also. When you find the area of 4 walls, it is the area including the doors and windows. So you must find the area of the 4 walls and subtract the area occupied by the 2 doors and 4 windows. That will be the resultant value is the area to be whitewashed. Multiply that by the rate to find the total cost. Yes, children? It's given area occupied by 2 doors is 5 meters square each. So that means 1 door 5 meters square, 2 doors 2 into 5, 10 meters square. If this word each was not given, suppose it was given if the area occupied by 2 doors is 5 meters square, that means by both the doors it is 5 meters square. This is the total area occupied by both the doors. If this word each was not there, that means the 5 meters square, this is the area occupied by both the doors. But what is given here? It's given that the area occupied by 2 doors is 5 meters square each. So 2 doors will be 1 door 5 meters square, 2 doors 2 into 5, 10 meters square. Similarly, 4 windows, area occupied by 4 windows is 1 meter square each. If this was not given, if each was not given, 1 meter square is the total area occupied by the 4 windows. But since each is given, that means one window, 1 meter square. So 4 windows will be 4 into 1, 4 meters square. Now find the area of the 4 walls, and from the area of 4 walls, take away the area occupied by the 2 doors and 4 windows. Take it away, remove it. So this is the actual area to be painted. This is the area occupied by the walls. The rest of the area is occupied by the rest of the area of the walls is occupied by the doors and windows. So the cost of whitewashing will be area 4 walls into the rate of whitewashing, which is this into 5, because it's given rupees 5 per meter square. This is the total cost. Yes, children, please start working. As you work, if you have any questions, please ask. And what is very important is 2h into L plus B. Be very careful while substituting. This is the length. This is the breadth. This is the height. So 2h, h is 20 into L plus B, 10 plus 35. Yes, children, please start working. Completed? So fast. All of you finished, is it? Yeah. Please write. Please write.
10, ma'am.
Yes, Bhavishya. Bhavishya, you understand?
Yes, ma'am.
So always when we find the area of 4 walls, using the formula 2h into L plus B, it is the area of the 4 walls, including the areas of including the area of the doors and windows. But we know that we will not whitewash the doors and windows. When we whitewash the walls or paint the walls, the doors, the paint which is used for the wall will not see the window and door also will be painted. But the paint used for the here it's distempering, whitewashing. So you will not whitewash the windows and doors, right? Yes or no? Whitewashing is done only on the walls. So you should find the area of 4 walls, but that includes the area of the doors and windows. So take it away. Subtract that. And then multiply that by the rate to find the total cost of whitewashing. And this is very important because sometimes we might know, but we'll go wrong here. Be very careful while reading the question. 2 doors is 5 meters square. If this word each was not given, that means for both the doors, the area, total area is 5 meters square. And here 4 windows is 1 meter square. That means the area of all the 4 windows is 1 meter square. But here, since the word each is given, 1 door 5 meters square, 2 doors 10 meters square. Again here each one window 1 meter square, 4 windows 4 into 1 4 meters square. All right. This you can no, we'll do this another day. 1 minute. Let's take up this. Yeah. Do the first one, children. See, this is a repetition because we have done similar sums earlier from NCERT. So you can try this. Find the area and perimeter of the figure given there. So this one is not a solid, children. It is a rectangle. This one is not a solid, it's a rectangle with semicircular ends. I hope you understood it like that. It's a rectangle with semicircular ends. Now tell me the length and breadth of the rectangle and the radius of the semicircle. Because for the rectangle, you need to know the length and breadth. Only if you know the length and breadth, you can answer any question related to the rectangle. Similarly, for a circle or a semicircle, you need the radius. If you have the radius, anything can be answered regarding the circle or the semicircle. So what is the length and breadth of the rectangle? What is the radius of the circle or semicircle? Tell me.
Shall I?
Yes, Swati.
Yes, ma'am. Ma'am, the breadth of the rectangle is given to be 7 meter, ma'am.
Okay.
Ma'am, so that will be the diameter of the semicircle, ma'am.
Very good.
So it's like 7 divided by 2 to find the radius of the semicircle, ma'am.
Very good. So the radius of the semicircle is 7 by 2 or 3.5 centimeters. Correct. And you also said the breadth of the rectangle is 7 meters. Correct. What about the length of the rectangle?
Ma'am, to find the length of the rectangle, we need to subtract 3.5 minus 3.5 with 40 meter, ma'am.
Correct. Perfect. Yes. So this is the radius of the semicircle. This one is the diameter of the semicircle. This is the radius of the semicircle. Similarly, this is the radius of the semicircle. So it's 3.5 here. See, this is the radius. You can complete the, see, look at this circle diameter. From here to here is the radius. This is the radius. This one is the diameter. So the radius is 3.5. Here also the radius is 3.5. Now what is this 40 made up of? 40 is made up of, this is the length of the rectangle. From here to here is the length of the rectangle. See here, from here to here is the length of the rectangle. This is radius, this is radius. So clearly radius plus length plus radius is equal to 40. What is 40? End to end it is 40 meters. End to end it's 40 meters. That means the radius plus the length of the rectangle plus the radius is equal to 40. Radius is 3.5 plus the length of the rectangle plus 3.5 is equal to 40. So when you work this, you will get L is equal to 33 meters. Very good, Swati. Yes, children. Now you can. Now you know how to find the area. So it will be the area of the. Yeah, who can tell me how do you find the area? Area of the figure. Area of the figure is?
The area of the rectangle plus the area of the two semicircles. Or
correct. Area of the rectangle plus the area of the two semicircles. How do you find the perimeter? What is the length of the semicircle? How much is this? What's the length of a circle? What's the circumference of a circle?
2 pi r square, ma'am.
2 pi r, not 2 pi r square, 2 pi r. So what is 2 pi r by 2?
Ma'am, pi r, ma'am.
Pi r. So this length is pi r. The length of the semicircle is pi r. Because the length of the full circle, the circumference of the circle is 2 pi r. So for a semicircle, the length will be half of that, pi r, 2 pi r by 2. So pi r. So this length is pi r. This length is pi r. What about this length? What about this length?
Ma'am, pi r.
Pi r. What about the length from here to here? How much is this?
Ma'am, 40 centimeter, ma'am.
Oh,
40 minus 7, ma'am.
how much?
40 minus 7, ma'am.
Yeah, 33 meters. What about the length from here to here?
And same, 33 meters.
33 meters. Yeah. So the perimeter of the figure is 33. That is the length of the rectangle plus pi r plus the length of the rectangle plus pi r. Yes, children, you are good to go now. Start working. Radius, you can take 3.5 or 7 by 2. That's your convenience.
Done, ma'am.
Done? Yeah.
Yes.
Others finish and let me know. Nandana and Bhavishya.
Last step I'm doing now.
Yeah, yeah. Please let me know. Finish it and let me know.
Completed, ma'am.
Yeah. Nandana? All right, let's see the answer again. So the first thing is to identify the plane figures in this entire figure. So the two plane figures here are, that is the whole figure is made up of two plane figures, one rectangle and two semicircles. So for the semicircle, you need to find the radius. Since the diameter is 7 meters, the radius will be 7 by 2, 3.5 centimeters. Now the length and breadth of the rectangle. Clearly the breadth of the rectangle is 7 meters. The breadth of the rectangle is 7 meters. The length of the rectangle is not 40 meters because 40 is from this end to this end. 40 meters is the length from this end to this end. This is not the length of the rectangle. This is the length of the entire figure. This is not the length of the rectangle. So the length of the rectangle is only the length from here to here. But this one together, the length of this entire line segment is 40. What do you have here? 3.5. What do you have here? 3.5, because that's a radius. That's a radius. So the full length 40 minus 3.5 on both the sides. So minus 3.5. That is, you're taking away 3.5 two times from either sides. So 33 meters is the length of the rectangle. The length of the rectangle. So now we have the length and breadth of the rectangle. We have the radius of the semicircle. Now let's find the area and perimeter of the figure. Area L into B, 33 into 7, 231 meters square. Now the area of two semicircles. The area of two semicircles. One circle, area of one circle is, children, pi r square. This is the area of one circle. Area of one circle is pi r square. Area of a semicircle will be half of pi r square or pi r square divided by 2. Half of pi r square or pi r square divided by 2. One circle is pi r square. So semicircle, the area of a semicircle will be half of pi r square. So what I've written here, half pi r square, is the area of one semicircle. Like that, we have two semicircles. So 2 into half pi r square. Please understand what I've written there. The area of one circle is pi r square. The area of a semicircle is half of pi r square. Half of pi r square. This is the area of one semicircle. Area of two semicircles will be 2 into this one, half pi r square. That's what I've written here. So 2 cancels and you'll get pi r square. Pi is 22 by 7. R is 7 by 2. R square is 7 by 2 into 7 by 2. So on simplifying, you get 77 by 2 or 38.5 meters square. So the area of the figure is the area of the rectangle plus the area of the two semicircles. Perimeter, as we discussed, it's the length of the rectangle plus pi r plus the length of the rectangle plus pi r. So L plus L is 2L and pi r plus pi r is 2 pi r. Substitute the values and calculate, you get 88 meters. All right, children. Yeah. Try this one. What's the length of the rectangle, children?
21 meter.
21 meter. What's the breadth of the rectangle?
14 meter.
14 meters. What's the diameter of the semicircle?
14 meter.
14 meters. What's the radius of the semicircle?
7 meter.
7 meters. How will we find the area of the figure? Tell me in words. I don't want the numerical answer. That you have to work. How will you find the area? How will you find the area of the figure? Like, I'll tell you what I'm expecting. Now here to find the area of this figure, it is the area of the rectangle plus the area of the two semicircles. Like that. Like that, how do you find the area of this figure?
We find the area. And we find the area of the semicircle and then subtract it with the area of the rectangle.
Okay. Bhavisha, what did you want to say?
Ma'am, we want to, we want to take the area for perimeter. Sorry, ma'am. We want to take the area and perimeter for rectangle. Afterwards, we can take like for semicircle. Ma'am.
No. My question is, how will you find the area of the figure? Only area. We'll come to perimeter later.
Area of rectangle first we should solve, ma'am. After that we should solve area of semicircle, ma'am.
Okay, then you should add or subtract to find the area of the figure.
Ma'am, we should add.
No. See, from the rectangle, the semicircle is taken away, right? Just imagine this is a biscuit like this. I'm just telling you. You've taken a bite like this. So it's reduced. No, the area is reduced.
Yes, ma'am.
Okay, just imagine this is a, a very thin piece of chips. Okay, some potato chips looks like this. So from the chips was like this earlier. Earlier it was like, oh, I'm sorry. The chips was a perfect rectangle earlier. When you got it from the shop, it was a perfect rectangle. Okay, so the area of the rectangle is 21 into 14. Then you took a bite like this. You took a bite like this. Now this area is missing. You've taken a bite like this. This is not there now. In this figure, this is not there. The area of the semicircle is not there because you've eaten that. That means that is removed. So you should subtract, right? It's the area of the rectangle minus the area of the semicircle. Yes or no?
Yes, ma'am.
See, if the area is missing, you should subtract. If you find the area of the rectangle, you're finding this area. See here. You're finding this area. When you find the area of the rectangle, you're finding this area. But actually, there is no area here. There is no area here. This is missing. The figure ends here. So the area of the rectangle minus the area of the semicircle will be the area of the figure. How do we find the perimeter? How do we find the perimeter? Perimeter will be 21 plus
14, 21 plus 14 plus the circumference of
no 21 plus 14 plus
plus 21, ma'am.
plus
21
21 plus
the circumference of the
formula. What is it?
2
How
pi
much
r
is
by
this
2
length?
pi r. Ma'am, pi r.
Pi r. Very good. Because this length is pi r. This length is pi r. We know that. So 21 plus 14 plus 21 plus pi r will be the perimeter of this figure. Yes, children? Please start working.
Completed, ma'am.
Yeah.
Ma'am.
Yeah, I'll wait.
Done, ma'am.
All right. So here also in this figure, we have a rectangle. The rectangle is not complete. The rectangle is not complete. So we have an incomplete rectangle, that is semicircular piece is removed from the rectangle. We don't have the complete rectangle here. A semicircular piece is removed from one side, that is the breadth of the rectangle. So length of the rectangle is 21 meters, breadth is 14. So this is the area of the rectangle. But when you find the area of the rectangle, actually you're finding till here, as if this area is also there. When you find the area of the rectangle, you're finding the area of this figure, as if this portion is also there. But actually this is not there. This is cut. This is cut. The figure ends here. So you must take away the area of the semicircle. Area of one semicircle is half pi r square. Because pi r square is for a circle, area of semicircle is half of pi r square. So half into 22 by 7 into radius is 7. Diameter is 14, so radius is 7. Diameter is 14, so radius is 7. Radius is 7. So this is the area of one semicircle. So the area of the figure is equal to 1 minus 2. Rectangle minus semicircle, because semicircle is not there. See, here we had to add, because in this figure we had to add to find the area of the figure. We had to add the area of the two semicircles, because this is the rectangle. The rectangle is only this one. But the area of the figure will be the area of the rectangle. There is a semicircle here, plus the area of the semicircle. There's another semicircle here, plus the area of the semicircle. It is there, so you should add. If it is not there, you should subtract. Here the semicircle is not there. This one is, it's empty here. It's not there. So we should subtract. Take away the area of the semicircle. So rectangle minus semicircle. This is the area of the figure. The perimeter is, as we understood, 21. Just go along the boundary. Plus 14 plus 21 plus pi r. The length of the semicircle is pi r. Pi r. So 22 by 7 into 7. 7 and 7 cancels. This is the perimeter of the figure. Is that fine, children?
Yes, ma'am. Yes, ma'am.
Okay. Yeah. Now, please take screenshots and complete this. I think only this, yeah. Please complete this, children. Find area and perimeter of the figure. Please take a screenshot and complete this one, all right? Let me just explain what it is. So this one is a square. This one is a square. On each side of the square, there's a semicircle. Do we understand, children? On each side of the square, there's a semicircle. In the middle, we have a square, and on each side of the square, there's a semicircle. All right? Okay.
Yes,
now
ma'am.
the height, yeah, the height from this point to this point, this total height, this one is 42 centimeters. From here to here, see here, from here to here is 42 centimeters. Now, what is it made up of? Now, this is the radius. This is the radius of the semicircle. If you see, this is the diameter of that is, this length is equal to the diameter of the semicircle, which is 2r. Diameter is twice the radius, and this length is equal to the radius. That's what you see here. R plus 2r plus r is equal to 42. I'll tell you again. 42 is from here to here. This is the radius, plus from here to here. This is the diameter, because this is diameter, no? This is diameter. So this length also will be, this is not the diameter of the semicircle. This line segment, it is not the diameter of the semicircle, but the length of this line segment is equal to the length of the diameter. This is not the diameter, but the length of this line segment is equal to the length of the diameter, is equal to the length of the diameter. So I'm saying 2r. Don't say, I'm not saying this is the diameter. The length of this line segment is equal to the diameter. This one is the radius. From here to here, the length is equal to the diameter. This one. And again, from here to here is the radius. is the radius. So this total length is 42. What is it made up of? It is radius plus twice radius, that is diameter, plus radius. This is equal to 42. When you work that, you get R is equal to 21/2 or 10.5 centimeters. So we found the radius of the semicircles. We found the radius of the semicircles. You can take it as 21/2 or 10.5. There are 4 semicircles. You can take the radius as 10.5 or 21/2. Now what? Now there's also a square. Now for the semicircles, we found the radius. What about the square? What is the side of the square? What is the side of the square? The side of the square is nothing but the diameter of the semicircle. You can see here, the side of the square is equal to the diameter of the semicircle. You can see here everywhere. Okay. So what's the diameter? The radius is 10.5. So what is the diameter then? Diameter is 2 into radius, twice the radius. So 2 into, see here, side of the square is equal to twice the radius. So 2 into 21/2 or 21 centimeters. Radius is 10.5 or 21/2. The side of the square is nothing but the length of the diameter, which is twice the radius. So 2 into 21/2, which is 21 centimeters. See, since we have two figures, that is semicircle and square, you need to find the radius of the semicircle. You need to find the side of the square. Now we got both. Radius here we have and side of the square here. Now the area of the figure is the area of the square plus the area of the 4 semicircles. This is the area of one semicircle, half pi r square. 4 semicircles, 4 into half pi r square. One semicircle area is half pi r square. Like that, 4 into half pi r square. So 2 ones are 2 twos are. So this will be 2 pi r square. In the next step, you see it is 2 pi r square. When you simplify, you get 2 pi r square. Area of square is a square. So substitute and get the area of the figure. Now the perimeter of the figure will be this length, go along the boundary, plus this length, plus this length, plus this length. That's all. You should not get inside the figure. Perimeter is the length of the boundary. So the length from here to here, plus this length, plus this length, plus this length. And this length is equal to the half the, half of a circle, semicircle. Half of this one is the semicircle. This is the length of the semicircle. The length of the semicircle is pi r. This is pi r. 2 pi r is the length of a circle or the circumference of a circle. The length of a semicircle is 2 pi r by 2, pi r. When it is area, children, area is pi r square. So area of a semicircle is half of pi r square. The length of a semicircle is, the length of the circle is 2 pi r. So the length of a semicircle will be 2 pi r by 2, which is pi r. So pi r, this is pi r plus pi r plus pi r plus pi r. So see here, that's the perimeter of the figure. Please take a screenshot and complete this, children.
Yes,
take a screenshot, children.
Yes, ma'am.
All right, children. Fine, children. So I've compensated for that 15 minutes delay of the last class. I hope you all realize that. Yeah.
Yes, ma'am.
Yeah. All right, children. All right, children. So that's it for today's session. Thank you so much. Please make sure by Monday you complete all the tests in the portal, children.
Ma'am, all the tests I have completed, ma'am.
Oh, you have completed all, is it? Very good. Okay. The others who have not completed, please make sure that you complete all the tests by Monday. All right?
Yes, ma'am.
All right, children. Thank you. You may leave the call.
Thank you. Thank you, ma'am.
Thank you, children.